All right, thank you, AG. This is awesome. A little nervous today because of doing this webinar. I've done a lot of podcasts and other things, but I've never done a webinar for InterNACHI, so I'm super stoked about it. I hope all you guys are too. My name is Dirk. I am a certified professional inspector and CMI on top of it. This is a electrical course 101. Okay, we're gonna go right to the basics. And the couple things is that I have over 100 certifications and degrees. I do have a 2-year degree in residential electrical. So I do know quite a bit about electrical and I really enjoy electrical. That's kind of my forte when it comes to home inspections. And I love being a home inspector. And I love to help everybody out too. So if you do have some questions that pop up and you don't really know what to say, and you can always email me back at askdirk cmi@gmail.com, and I can get back to you that way. Okay. To start the webinar, we are going to go through a little bit of topics of discussion is histories, and then we're going to go into the fundamentals of electricity. Then we're going to go into Ohm's law, the safety concerns, and then the inspection process. And then if there's any more questions, we're definitely want to answer those as soon as I possibly can because I really want this to be interactive and I want you to be part of this. Okay. Let's just get started here. The fundamental facts. What is electricity? Okay. What is electricity? Electricity is a form of energy that can make things move or work. Or the dictionary explains it as a form of electricity resulting from the existence of charged particles such as electrons, protons, either statically or accumulation of charge or dynamically as a current. Okay. So here's a little question for you. What year is credited for the discovery of electricity? Anybody out there? Give you a few seconds to type in on the webinar chat here. Any idea what year it was that electricity was discovered or credited to be discovered? That's what I thought too, honestly. But no, you are wrong. It has not been in the kite key. It is actually this guy right here. See, he has more hair than I do. Um, he found out that rubbing a piece of fur on a amber would actually cause static electricity. He actually thought it was magnetism. Little cool fact is electron comes from the Latin word electricus, which is from the Greek word amber. So that's how electrons form. Then we also know that anybody know who this guy is? He's actually the father of electricity. Again, I thought it was Ben Franklin. This guy is definitely not Ben Franklin. Does anybody know who this guy is? Give a few seconds here. All right, his name is Michael Faraday. He was a British scientist and experimental physicist, and he was known for the father of electric motor generator and transformer, and is credited with discovering the principles of electromagnetic induction. And he was born in 1791 and lived to 1867. Now, the guy that we all know and love, and his face is on the $100 bill, is Benjamin Franklin. And he was a founding father of the United States and leading figure in early American history. He was a printer, author, scientist, inventor. You guys can read the rest of that. Anyways, Benjamin Franklin's also one of his inventions, besides the bifocals, and I think he invented the catheter too, so you can thank him for that. And he also did um, make something that we use on a regular basis, and that is actually called the lightning rod. Okay, and a lightning rod, he was invented and it was called the Franklin rod. And he believed that lightning was electricity and that it pointed metal needle could draw electricity to it and charge a metal sphere. He put the first lightning rod on the roof of his own house, hoping to encourage others to do the same. Although he put a patent on the device, he gave it to the rest of the world to help others. So that's pretty cool. Here are some other, here's another diagram on how it actually works. The lightning rod actually directs it around the building so that your building doesn't set on fire. And it's pretty common here in mid-Florida. And that's where we're at. Here's some other people that are pretty famous that helped generate what we now have as electricity. And if anybody knows any of those names, we got William Gilbert up on the top left there, and he was born in 1544, and he created the science of magnetism, and he was the discovery that Earth was a big giant magnet, and he also did pioneering work in electricity. For this, he was celebrated as by the physics community. James Clerk Maxwell on the right there, he is one of the greatest scientists of the 19th century. He was best known for the formulation of the theory of electromagnetism and in marketing the connection between light and electromagnetic waves. So everybody knows Thomas Edison there. He was born in 1847, and he found out 1,000 ways of not to make a light bulb, and that's what he is most contributed for. The next guy over there is Nikola Tesla. He was born in 1856, and he was an inventor, engineer, and futurist who made many breakthroughs in the production of transmission and of applications of electrical power. He is known for the contributions to the design and modern alternating current, the AC, electricity supply system. Tesla also invented the Tesla coil in 1891, which laid the foundation for wireless technology and is still used in radio technology today. Many of his own designs were lost when he died. So pretty cool stuff here. But, oh, go to the next screen. Okay, there are how many types of electricity that we are aware of? Does anybody know out there? If anybody answers this one. There's actually two types of electricity. And it isn't AC and DC. It's actually, you got static electricity and you got current electricity. AC and DC is actually part of current electricity. And there's your other type of electricity. And a lot of times the electricity will be flown from your house to, or flown, flows to your house through the grid, or sometimes your own power station, which would be your solar panels. And then it's converted from DC to AC. AC can actually go further down the line. So that's why we use AC instead of the DC current, which can dissipate over many miles. So that's why we do the AC instead of the DC. All your solar panels and stuff actually are DC converted into AC, or start charged into batteries, then converted back to AC. And we'll do a different podcast on that later down the road, hopefully. So electricity is the flow of electrons through wires, right? Everybody knows this. This is like 7th grade science, if you remember that. And it either goes above ground or below ground. On the left there, you always see the towers, or the telephone wires is what they normally call them, but those are definitely power lines, and they run into your house or underground, like you see on the right side there, underground up into your electrical meter. Okay. We're going to get into the flow of electrons into atoms. And I know this can be complicated. It can be confusing. Just bear with me, okay? Electrons move around the nucleus of an atom in a circular orbit called shells. These number of electrons that each shell can hold depends on the shell, with the shell closest to the nucleus holding 2 electrons and the outer shell holding more. The electrons in the shell closest to the nucleus are strongly attracted to the nucleus protons. Electrons in the outmost shell may not be strongly attracted to the nucleus and can be pushed out of orbit. So they can be attracted to other things too. So that's why electrons move. They're constantly moving. Okay. I want you to kind of think about how electricity flows. Now, the best way that it was described to me is like water. And everybody kind of goes to this. It's not 100% right on, but it kind of gives you an idea. Okay. Electrons flow in wires like water from a garden hose. The bigger the hose, of course, the more electrons can push its way through there. And the smaller, of course, the less electrons. So if you take an 18 gauge wire and you try to put a 20 amp circuit on there, guess what? Those wires are going to burn up because there's just too much electrons for that wire. But if you put a 6 gauge wire or something like that, the electrons are going to flow nice and smooth. So that's why we want to check the wires. The difference between water and electricity, water is predictable, very predictable. You can always know that it's going to travel the least resistance. You know that when you go up on a roof and you're looking at shingles and how the water is kind of, there's a wet spot in the underneath the sheathing there, you're going to figure out that the water is kind of flowing in the least resistant area. Where electricity, it wants to travel in any direction. So it doesn't matter if it's upside down or sideways or whatever. Electricity is always going to flow. Okay. Keep this visual of the hose and the water just pouring out of that hose. Okay. Kind of keep that in a mental um, fundamental in your head, especially like when you're doing your home inspections and things like that. So voltage has three factors in electricity: is voltage, resistance, and current. Again, this may get confusing. Just stick with me. I'm going to try to go through this Ohm's law so you understand it a little bit better. Okay. So when you're looking at voltage is always represented as V or E. When I was in school, it was actually E. They changed it. And I'll get into that a little bit later. And then resistance is always represented as R, and current is represented as I. Okay. Resistance is measured in ohms. Anything that slows down the flow of electricity is like narrowing the part of the hose that reduces the flow of water. So, the Greek letter omega is the ohms symbol. Okay. The ohm is the unit of electrical resistance in the SI, International System of Units. It is named after the physicist George Simon Ohm, who studied the relationships between voltage, current, and resistance. Okay. Pinching the water hose, that's resistance. It's going to slow down the water flow, and it might actually get you wet too on top of it. So don't do it too often. Current is the flow of electrical charges, electrons. It is measured in amps. The amount of water flowing through the garden hose is amps. Okay, voltage is the push that makes the electric charge move. It's like the pressure in the water hose. Okay, so I understand like some people just get totally confused by this. So I found this picture online and it actually kind of describes it pretty good. So if you look at the little narrowing there, that's the ohms. Mr. Ohm is trying to stop the running amp from reaching the target, which would be your light bulb or maybe even your air conditioning unit. Uh, well, the coach, the volt, is pushing him through there. When the amp makes it there, he rings the bell and work begins, known as watts. Okay, so this also helps too. The water pressure. The bigger the hose, or and the bigger the pipe, the more water can flow through there and creates wattage, which is your work that's being produced. Okay. This is relevant because it provides you the foundation of understanding, designing, troubleshooting, and working safely around electrical systems, making it essential knowledge for anyone involved in electrical or electronics industry. Knowing a little bit can also help you communicate properly to your customers. So that's why we want to learn this a little bit. Okay, the Ohm's law is basically this giant triangle, V up on the top, I on the left, and then R on the bottom right. Okay. And then you can actually do your calculations just knowing that little bit right there. Okay. When you're an electrician, you have to constantly go back and actually figure this out for size wire and the resistance factor and things like that. As a home inspector, you really don't have to measure that too much. Here's another difference of Ohm's law and the circular pattern. You can get this right off of InterNACHI too, which is really cool. Okay, the proper applications for this, the volts, V or E, electromotive force, that's what the E stood for. Current is I, intensity, and then resistance is the current and represented as R. So, and this is why it's important to know. Okay. The power law. We're going to go into the power law. It's either pi or PIV. Just stick with me. Okay. This gets a little bit more easy and you can actually understand how this is working in your day-to-day lives. Okay. So the power law is the bottom part here. And power law is simple and it uses daily from millions of homes across the world. Okay. The power law. Okay. And basically, same thing here with your circle. We're going to actually use this as an application. Okay. This is why it's really important to know this. Okay. So my wife's got a Casio electric piano. Okay. And it has an adapter on there. And then we also have this diffuser or fancy humidifier where you put the drops in there and it helps make the room smell better or whatever it is. And so, anyways, I took little shots of both those transformers that we plug into the wall. Okay. So what we're going to do is we look in there and you see the input 100 volts and then it's 0.457 amps. Okay. So if we times 100 times 0.457, we get 45.7 watts. That's how much volt or how many watts we're using per hour, 45 watts per hour. That's why it's important, like when you're looking at your electrical bill and stuff like that, that you're unplugging a lot of the stuff that is useless. When you're done charging your phone, if you unplug it from the wall, you can actually save yourself some money. It's not significant amount, but it is a little bit. And you can do the same thing with this transformer here too. It's 100 amps or 100 volts going into I think it was 47. I can't really read it. Truth. Let's see if I can move this. Yeah. Sorry, it's kind of a little blurry there, but it's like 4 amps and again it equals to about 45 watts an hour. Okay. Hopefully that understand. This is why it's practical. On an incandescent light, you're going to work about 60 watts per hour. And so the new LED lights, you're only going to use 10 watts and it's going to have that same luminous that the incandescent light has. So this actually can save you a lot of money. So your customers, when they're asking you about saving money, you can actually help them with this saying, hey, if you would check out LED lights instead of getting these incandescent lights, get the ones that are dimmable and you can save yourself a lot of money. Okay. When you're looking at your electro electrical meter, there's a couple things that you look at is your watts per hour. Remember, I was just talking about that. That's written in the like light blue there, and you can actually see that it says watts per hour. That's what we're getting billed for. When you're in rural areas in the United States, a lot of times you have to write down that number and send it to the electrical company so that they can charge you accordingly of how much wattage you're actually using on your house. And kind of know this too is that when you have things that are unplugged from your house, you are still using electricity because there is resistance in the wires themselves. And the only way to actually stop that is by stopping the electricity itself by the circuit breaker. So just kind of keep that in mind too. Safety concerns. We're going to kind of go into the safety concerns of electrical systems. Okay. Safety always comes first. You're going to hear me say this 1,000 times. When I'm mentoring and training other home inspectors, I always tell them, be cautious. I fell off a roof in 2020 because it was a little slippery. I lived up in Minnesota and there was a little bit of ice and I broke my arm. I know inspectors that have had similar things happen to them because they didn't take the safety precautions. Okay. When it comes to electrical, according to the NFPA, which is the National Fire Prevention Association, also helps with the NEC, the National Electric Code. Home and electrical fires account for an estimated 51,000 fires each year, nearly than 500 deaths, more than 1,400 injuries, and 1.3 billion in property damages. So keep that in mind when you're doing your home inspections and if you're helping friends or whatever it is, that electrical fires really are they're it's just 51,000 fires. That's a lot. It's a lot of fires. And a lot of them can be prevented. Um, I know in Florida here we do have our 4 points uh, inspection form, and they ask us if we see any heaters that are plugged in and used for heat because again, it's electrical fire hazard. So, rule number one, safety first. Remember, I think I said that before, and I hope Everybody gets that in their head. Safety, safety, safety. We are safety inspectors. We're not code inspectors. Safety first, okay? Use caution. Always use caution when you're dealing with electrical panels. There's a couple of electrical panels out there, and you probably have heard of these before. I've ran into a dozen of these plus. Zinco, Magnastrip, Sylvania, Challenger, and GTE Sylvania. These are the problematic panels. When you come across them, a lot of times you look at them, you're going to look at those circuit breakers. When you see those type of circuit breakers that are colored and they're kind of thinner, you know that maybe further evaluation from an electrical professional. That's definitely normally what I call it out. These ones aren't as problematic as some of the other ones. These pushmatic ones are, they end up corroding after a few uh like 10 years or so, and they end up not working properly, and so they won't trip when they're supposed to. And the same thing with those other circuit breakers, they don't trip the way they're supposed to. So we would definitely want to, when you see them, call them out right away, okay? Um, but we all know about the Federal Pacific. I have dealt with hundreds of these Federal Pacific panels, and I know two home inspectors that had an accident with these. And I always tell, like, when I mentor home inspectors, don't take the panel cover off. One of the first ones that I did, a couple of the circuit breakers actually fell out on me, and I had to put them back in. And I was thinking, well, I am an electrician. I could probably do it. And I really shouldn't have. I really shouldn't have. Um, and then my boss that I worked with said, don't ever take them off. And so after doing research and stuff like that, I actually talked to a couple of home inspectors in Texas. This one actually had taken the cover panel off and it exploded on them. Okay. This is dangerous. Okay. So I recommend everybody, if you see them, call them out, say further evaluation from a licensed electrician. We're all in it to go home safe. Be safe when you're doing this. Okay. It's not, I can't preach on it enough. The reason why is because of these arc flash. If you've never seen an arc flash, this is an arc flash. Okay. Arc flashes are dangerous. And if you want to do a YouTube video on it, there's tons of them out there that will show you when people actually have had arc flashes. And there's been a few deaths that's occurred because of these things. Okay. They can reach temperatures of 5,000 degrees in an instant second. Okay. Up to 35,000 degrees Fahrenheit. Okay. So when that happens, it's instantaneously everything turns to a gas and explodes right on you. And if you don't have that panel cover in front of you, you are going to get hit with all that, and then it turns into shards, and you're going to be in some serious pain. Last year, 2 years ago, I had a customer call me up and say, "Hey, what do you know about electrical?" And I said, "I know a little bit." And they said, "Well, we had a guy that was hooking into a panel with solar panels, and he accidentally caused an arc flash." And so I said, okay, I can definitely do this for you. So I did go to the house and did a whole home inspection on the house. And the readings I was getting from the electrical wasn't good. And it's almost like a lightning strike hit that panel right away and blew the whole system. So they are dangerous. Okay. Um,
Hey
so
Dirk,
just,
we do have a question. I don't know if you saw it from Mark. He
nope.
asked, "Are all your stats for USA homes or North America?"
North America. Sorry, I didn't see that one. Yeah, I got it open here. It says Mark, but I don't see. Okay, yeah, I see all stats. I got to click on it. Sorry about that, AJ. Thanks for getting my back. So just so you know that the arc flashes are dangerous, you know that it goes up that high of temperatures. The temperature of the sun's 9,000 degrees, so it can actually reach past the sun's temperature. So that's pretty pretty scary stuff. Okay, so be cautious when you open up those panels. Okay, the best thing that I've ever been taught was feel the panel with the back of your hand. When you go up there, feel it with the back of your hand. You don't want to put your palm of your hand on there because you have moisture on there and it could actually suck you to it, or you might uh, lose your mobility and actually grab onto something. So that's why you touch it with the back of your hand. If you feel a little tingling, guess what? Don't go any further than that. It's not worth it. Just call it out. Say, hey, listen too. If you hear humming, things like that, can give you indicators that there's something that's not quite right. Okay. Further evaluation. Super easy. It's good to call that stuff out. Okay. Um, this is something that I have set up in my workshop when I'm doing mentoring other home inspectors. I actually have this set up so that we can actually practice on it without having to worry about live electrical. So first thing you do is when you get there, open up that panel cover and look in there and look at your circuit breakers. Okay. And just kind of give it a quick look over. And in a later webinar, I'm going to talk about balancing a panel too. And a lot of home inspectors don't even realize how to balance a panel. And I'll talk about that in a later webinar. So open up the panel, check out the circuit breakers, look for anything that looks outside the normal. Sometimes I've seen melted circuit breakers on there. Um, a good thing to do is when you're doing your home inspection, you look at your condenser unit outside and check out that max fuse or circuit breaker. It says 25 amps. And then when you go to the electrical panel, open it up, see if it's 25 amps. If it's not, and it's more than that, guess what? That um, air conditioning unit might be voided because of the higher amperage. And so we want it to trip at the 25 amps. Other words, what can happen is what they call startup energy is when the motor turns on, all those electrons are flowing through there and it's hitting it. And let's say that motor doesn't start up, but it keeps sucking that energy, right? And it's absorbing it. Well, at 25 amps, it's going to shut off. But at 30 amps, it might start a fire. So that's why it's very important to actually check that out. Sometimes even your water heaters, your electric water heaters will have max fuses on there. I haven't seen too many of them, but they do sometimes over uh, breaker size them. That's what they called. So anyways, so that's really important. So you can see that's 25 amps, the 30 down below, the red flag, but we want to see the 25 amps. I was in a discussion group once with an inspector who was kind of newer. He goes, they don't make 25 amps. I said, circuit breakers. I said, yeah, they do. I've seen them. I put them in. There they are. So had to get a picture of it, put it on there. So remember, think safety. Safety always comes first. I bet you've heard that before. Safety comes first. Arrive safe, work safe, go home safe. We're all in this for our families or trying to get some money. Go home safe. We all want to be safe. Okay. Wear safety equipment. Like I always carry a pair of recordable safety glasses, and you can get those on Amazon. And I put those on, and every once in a while, I will actually record something with it so that I remember that they actually can record for um, camera. The other thing is use some PP equipment, okay? Glasses, a hat. Some people actually put gloves on, rubber gloves. Some people put a hard hat on. I have a hard hat that I wear only when I do new home construction. I don't know. Yeah, we're due 4 points too. And they do when I come across these Federal Pacific panels, I say too dangerous to take off. Further evaluation, just leave it at that. There's a slot in your 4 point inspection that you can do that. Remember, you're gonna go home safe. They're gonna tell the homeowner that they're gonna have to replace it anyways. So during the 4 point inspection, that's a good question though. I hear that quite a bit, and I say further evaluation.
Could you repeat that question?
Okay, so the question was, you don't, if you're familiar with the 4 point inspection, I live right here in Florida, and they say to take off the panel cover of the 4 point inspection. That is a great question. And I tell people, don't take the cover off. Put in there, it is unsafe to open. That's what that little line there on the bottom there is. You can not put a picture in there, or what I do is I just snap a picture of it and say unsafe to open and leave it at that. Sometimes I'll even put it in the caption of the photo too. So that is a great question, and a lot of people have asked me that. I know a lot of inspectors that actually take those panel covers off, and after I've learned a few people that have had them blow up in their face, Yeah, that's enough said there. So again, when you're taking those electrical panel covers off, you can wear safety equipment. Some people they actually even wear a safety shield too. So that is something, it's totally on you what you want to wear. Okay. And the way I was taught in electrical school is oh, when you take off a electrical panel, you do it in a star pattern, kind of like when you're taking your lug nuts off uh, your wheel of your car. So you start with one corner and you just kind of crisscross them. I always like to leave the last screw there because I'm right-handed on the right side, so that way I can hold the panel cover with my arm like that, and then I undo it. So that's the reason why I do it like that. If there are only four screws on there, just take your best guess and, just try to keep it so that the panel cover is going to come off nice and smooth. Something else I've done is I've taken my electrical uh, tester there and I put a magnet on the back side of it and I glue it on with 8500 glue. And that way I got a place to put my screws. And when I get to those electrical panels that don't have a way of getting them off, I can use that as like a handle. So kind of be a little proactive when you're doing it. We're all entrepreneurs when we're home inspectors too. So it's kind of fun. Okay. Again, you want to keep that door closed when you take off that electrical panel because you're going to have open circuit. So you want to close that and then take it off, hold it up to your face just in case something does happen to arc or blow up on you, basically. One time I've taken off a panel cover and there was a rat's nest in there, literal rat's nest. I'm not going to tell you what I did with that. So PETA might get mad. Anyways, the other thing is when you take off the electrical panel, you can see that there's a rat's nest of wires in here. And so I followed all the wires here, and I think the lowest circuit breaker here was a 20 amp circuit. And so I'm looking and I see, okay, so we got a question. Do non-contact testers detect a panel that is live shock hazard? Sometimes yes, sometimes no. Okay. That's why I like to use the back of my hand with that. Your electrical testers will tell you that there's electricity there. Like I got one that's super sensitive and then it's got like a dial on there. And so that way I can actually follow electrical lines right around between sheetrock. So it's really cool. Okay, so like your picture, I've been given mixed answers. Can neutrals and grounds be under the same bus bar? Only on the main panel. After that, they're supposed to be separated. Now, this house was built in 1970s where that wasn't the case. So like if this was a new home construction, I put it as a red. Like this is red flagged. But because it's in the 1970s, okay, this is a recommendation that they should be separated. So good question there too. Very good question. The other thing that I noticed, like when going back on the circuit breakers, that the lowest breaker there was a 20 amp circuit breaker. Every single one of those wires that were coming off there were 12 gauge wires. Then I followed the 12 gauge wire and it goes to a 14 gauge wire right inside the electrical panel box. So again, that is a safety hazard because the 14 gauge wire really shouldn't be taking on 20 amps. So kind of keep an eye on that kind of stuff when you're doing the electrical panel. So here's some terminology for you. Okay. So when you're looking at an electrical panel, and this can be upside down, sideways, there's only one electrical panel that I like to call it out because I see it. Simmons actually makes one that says this side up. And it's kind of funny because they have hooks that actually go inside there and help hold the panel cover on. And that's the only reason why it says that. But it's pretty cool because electricity really doesn't care. Um, so you got your service conductors that come in from the top there. And they can come from the bottom. Then you got your neutral wire. Normally that's white. If it's not white, a lot of times the electricians will tape it. Is there a main bonding jumper on the sub panel? There should not be a main bonding jumper on the sub panel. Sub panels should be separated. according to, I believe, 2015, the code changed. But we are not code inspectors, we are safety inspectors. Like this house that I live in is built in 1983. It was common for everything to be put together. And I think in another webinar, I'm going to do a talk about grounding and bonding because there's a lot of questions with grounding and bonding and how many grounding uh, bars you should have in the ground and so on and so forth. And it gets really confusing. And I totally get that. Totally get it. So let's go back to the terminology here. The service conductors coming in from the top. A lot of times you'll see that neutral conductor. Now, on older homes, they never wrapped it with white tape. So just know that when you open up that panel, that guess what? All three wires are black. And it's like, okay, all right. We always check for aluminum wiring and things like that. And I think in a later podcast, I would love to, or a webinar, I would love to actually talk about aluminum wiring too. So I'm not going to go into too much detail on that. Uh, so your main breaker, normally today's homes are 200 amp services that are coming into your house. A lot of them are 100 amps. Back in the 60s and stuff, they were only like 60 amps. So we've used a lot more power these days. So your main bonding jumper, as the question was there, you can see it. Well, you can't really see where I'm pointing, so I don't know why I'm pointing at the screen. Um, Main bonding jumper is so that the neutral and the ground are connected. That gives the ground or the neutral another place for electricity to find its way home. That's why you have the ground there. Okay. And then you got your bus bars that are hot on either side, which are connected to that main circuit breaker that will shut down if you turn that off. Then you got your neutral bus bars and your crossover bars and, well, your grounding wire there. I think you guys can all read that. And here is a little bit more diagram on it. So when you have your circuit breakers put into place and how they're basically put on there. I don't know. So the gutter posts, those are actually designed so that your wires go on the outside of that. I actually did some work on one of these panels once, and the way we used to do it is we'd have to bring the line all the way up, and then we'd have to bring it down if they were coming from the bottom, and if it's from the top, we'd have to bring the wire all the way down and then circle back up. A lot of electrical panels nowadays just go right to the breaker. I kind of like the whole loop thing because that gives you a little extra if you ever need it, but that's just personal. Anyways, I don't think there's really anything really to talk about here. You do see, I don't know if you noticed this or not, but it says that each bus bar on the hot energized side is 120 volts each. And if you look at today's terminology, it always says 110. It can go up to 120, so your 220 is actually 240. So there's a lot of extra voltage there can be in a panel. So just be cautious again when you're taking these apart. Okay. Um, I open up the door back or open up the panel door before I put it back on the electrical panel. And so then I close the door, realign the screws, and remember electricity is dangerous and a healthy respect for it can make all the difference. Okay. And in conclusion here, we're going to say electricity can be dangerous. I said it before. Remember, be safety. And using these safety tips and procedures can keep you and your customers safe. When you're not feeling right about something, don't do it. Okay. And I always recommend further evaluation from a licensed electrician, especially if I don't know what's going on there. Okay. I did take a electrical panel apart once, and they actually had Cat 5 in there as the wires. Couldn't believe it. First time ever. Like, why? People. um, Let us recap on what we learned. Okay. Electricity comes from a source through wires, either above ground or below. The distribution of this comes from your circuit breaker box or electrical box. Taking the panel cover off can be dangerous. Always use caution. Examine Examining of the circuits should be related on the size of wire and equipment. I always take the smallest and then work my way up from there. So that way you get a good indication if you're looking at a 15 amp circuit breaker, you're going to have 14 gauge wire. 20 amp, you're going to have 12 and so on and so forth. So you can kind of gauge it in your head. Other words, go to like a Home Depot or something like that and just get little clips of wire so that you understand. Or you could probably ask an electrician. He would probably have some on hand. I always refer anything out to be re-examined by a licensed electrician when in doubt. Okay. Always kind of protect yourself no matter what. Um, so in this, I got this from InterNACHI, and it's really cool because it actually kind of teaches you a little bit more about electricity and how it flows. As you can see, it goes from the electrical power lines into your meter, from your meter into your circuit panel, into the circuits. The circuits just displays that all over your house. I kind of look at it like your veins in your body is like the circuitry of your house. That's kind of how I look at it. Um, then it goes through the outlets and lights and so on. Okay. The best job is the one that allows you to return home at the end of the day with a sense of satisfaction, knowing that you've made a positive difference in the world and in the lives of others. So always keep that in the back of your head. Make sure all panels have bushings are required. Yes. I think now we're actually I can answer any questions if you guys have any up on the board. Age-old question, what exactly is cloth wire? The old school knob and tube stuff, or are we also calling thermoplastic wrapped and braided cloth rayon cloth wire? This is critical for insurance purposes. Whenever I see cloth wire, you know that it's older. You always know it's older, so I always just kind of call it out as an overall generalized everything because other words people are going to get so confused. Well, it looks like cloth wire, call it out. Knob and tube, I always like to take my electrical tester or my voltage sniffer and just make sure they're live. I've done a lot of 1800 houses and 1900 houses, and I love to see the old knob and tube. It's so, to me it's so fascinating because it was such a remarkable time in history when that happened. And they would put all these knob and tube everywhere. I went into a house in South Minneapolis one time, and that's all they had was knob and tube throughout the whole house. And um, I just said, you might want to update everything here. I mean, it's definitely just a cool system, but it is a little old. I see a lot of electricians do wire on 200 amp. That was acceptable for a while. So because and then they ended up putting the ground wire on there, and then so it all depends on the age. Because I believe the NEC actually calls that out now, but back in the day that was okay. So just kind of keep an eye, understand where that is acceptable. So yeah, update panel. It's always a good idea to just say, this should be updated. Okay. There is a huge difference between true cloth and cloth over rubber. And when you're talking answers for the insurance purposes, you are correct. There is, like I said, I like to just looks like cloth, just call it out. Because someone else is going to come along and just call it out anyways. When customers thank you for blunt screws, it's cool. Yes. I actually keep a couple of those screws in my pouch, and I try to swap them out right away because it's just so irritating to me. I don't know why. I do use thermal imaging for my inspections. Um, so basically, I forgot what anything that is, I believe, 160 degrees is not acceptable after 160, I believe, but I could be wrong on that one. It's been a while since I've had anything that's more than 120. So, uh, I love thermal imaging. I think it's one of the best tools that you can use in a home inspection. And it can also teach you, uh, like one time I was going around and I saw this outlet and it was red hot on the one side. And I looked and I'm like, Oh my gosh, that is smoking. And I would not have caught it, I don't think, um, right away. It was that thermal imaging that actually caught it for me. And so it turned out that there was a loose wire in the back of that uh, electrical outlet. So that was kind of cool. I love finding things like that. I don't know about you guys, but I just love to find things. Okay. Um, any other questions anybody have? Like I said, I think I'm definitely going to do a couple more webinars about aluminum wire and copper. And they do have different heat signatures because aluminum wire actually heats up a little bit quicker than the copper because it is more resistant factor. So, and his question was, does aluminum wire and copper have different heat signature? And yes, that is. So hopefully everybody learned a little bit here. No, thanks, David. I appreciate that.
I do want to address a question that was asked, but the person I think has left the webinar since. He asked if it is required to take off the panel, and I just want to remind everyone that the SOP does not require you to take off the electrical panel.
Mhm.
That is going beyond the scope, and if you choose to do that, that is on you.
Yeah, I addressed it because he was talking about the Federal Pacific panel because of the 4-point inspections that we do here in Florida. We actually, I tell people as soon as I see them, I take a picture of it. I actually have a little thing that I put on there that says unsafe to open. I love to help other home inspectors out. Again, ask dirkcmi@gmail.com if you do have any questions from this webinar. Have a good night. Goodbye, everybody.